All right, well, hello again. So this is part two of our perimeter, circumference, and area video lesson. And I'm glad I split it up because that first video is 25 minutes long. That's probably because I talk a lot. But anyway, so part two, I am devoting solely to circles because, again, circles are their own creation. They're a little weird. They have their own formulas. And along with just doing area and circumference of a circle, I want to talk to you about the area of a sector in a circle. We'll talk about what that means. And we'll also look at arc length, okay? Because I think those are important subtopics of area and circumference that I think need to be brought to your attention because they might be asked about them on the ACT. So let's get started. Now, we're going to look at area first, and then we'll look at circumference, okay? As far as the area and circumference of a circle, that should be familiar to you. It should not be new. Sector and arc length are new, but I don't think they're that bad, especially when you have a graphing calculator. It makes your life so much easier. Now, area for a circle. We all should know what this is. You should be saying it with me. The area is pi, my favorite number, r squared. Okay? Now, I know when we say the formula, we always say pi r squared because pi is a constant that is always involved with circles. But in practice, normally pi goes at the end, so you could also think about it as r squared pi. Okay? And when I do an area problem, I always want area or pi at the end. I just think it looks better. So you can remember it this way, but usually we write it this way, okay? Also, sometimes you will, obviously if you know the radius, we're good to go, but sometimes they'll give you the diameter. That's what this D is for. So make a note here. If we're given the diameter, we need to find the radius first. So find the radius by I don't know how to say this, but sorry, I was trying to think of a way to put that in words, but it's hard to do. So we need to find the radius first. So remember, the radius is half the diameter. So if you know the diameter, divide it by 2 to get the radius, okay? And sometimes you'll have that. So you need the radius for area. Okay? That's not new. This is a little bit new. So a sector, if you think about a circle like a pizza, we would think of a sector as a slice of pizza. It is actually a fraction, I'm using that word for a reason, it's a fraction of the area of a circle. Okay? So think of sector as pizza slice, the entire slice. And so it's going to be a fraction of the area. So it's going to involve this formula, but only a fraction of it. So I want to talk about that fraction for a minute. So in an area, or area of a sector problem, you need to know two things. You need to know the radius, which they'll give you. And then there's this x degrees right here. That's this angle right here that I highlighted with my little arc. That is called a central angle. We didn't really talk about those, but it's fine because we're going to mention it here. A central angle is an angle whose center is at the center of a circle, whose vertex is at the center of a circle. Excuse me. You need to know that central angle. It's going to help you get this fraction. The fraction is going to be x out of 360. And if you think about it, that kind of makes sense because we know that all the way in a circle, there's 360 degrees. And if I ask you for regular old area, you're going to use all 360 degrees. so you don't need to worry about this fraction. But when I ask you for only a portion of the area, like the sector, that's where this fraction comes into play. So it's the fraction times the area formula, pi r squared. Okay? So this is how you find the area of a sector. And then this is regular circle area. So let's look at a couple of these. So there's two area problems of a circle and then two sector areas. So find the area of the circle. And then I'm always going to tell you this direction. Leave your answer in terms of pi. So I'm doing this for us mainly because I find it easier. You don't always have to do that. Sometimes on the ACT or in real life, you're not going to leave pi in the answer. You'll actually need like the decimal equivalent, and I'll mention that here in just a second how you get that. But for our purposes, we're going to leave pi in our answer, just to make life simple. I think it's simple. Anyway, and I'll show you how to do that. But just know we need pi in our answer. So let's look at what I gave you. There's a 26 yards, and notice that it is the diameter. I need my radius. So I know to take half of the diameter and use that. So my radius here is going to be 13. 13 yards to be exact. So then area is going to be pi times 13 squared. Now see, look, I already told myself I want pi at the end, like up here, and look what I've done. I put pi in the front. So if you do that, that's fine, but no, I want the number first. So 13 squared is going to be 169, and then I'm just going to put pi at the end. This is an area problem, so this would be yards squared. So this would be my answer. Okay, so when I say leave answer in terms of pi, essentially what you do is you type everything up here in a calculator except the pi. So you could just mark that out, figure out what 13 squared is. It's 169, and then slap the pi on the end. That's kind of that's really all you do. Okay. Now, if you wanted the actual numerical value of this, all you do is just type that into a calculator. So 169. And then if you look at your calculator, right here in blue, above this caret key, is the pi symbol. So we have to hit second, that one to get pi. Then if you hit enter, that's the actual numeric value of that answer. So you would obviously need to round it. So this answer is about 530.93 square yards. So that gives you a better idea of how much area is inside this circle. Okay. But again, for our purposes, I'm going to stop here. If you want to go ahead and put the decimal equivalent, that's fine. Doesn't matter to me. But I just want you to be able to get here. Okay. I gave you the radius here. So we're good to go. So pi times 2.9 squared. Remember, the number comes first. So this section is what I'm going to type in the calculator. And when I did that, that gave me 8.41. And then I slap my pi on it. And notice I have feet. So this would be feet squared. And again, if you really want to know how much that is, just type it in. So that's about 26.4 square feet inside that circle, roughly. All right, find the area of the shaded region. So I think on your homework, the sectors aren't shaded, but it is kind of like the outline is bolded for you, so you know which one you're supposed to do. It'll say find the area of the sector or something like that. Now notice I didn't give you any radius length. That's why I put this up here. BC is 16 feet. So go ahead and put that in here. That's your radius. So now we're going to use this formula, okay, because it's a sector. So we're going to say area is, use the angle, central angle, 51 over 360 times, and then we use the area formula from earlier. Pi times 16 squared. So now I got to talk about typing this in the calculator, because again, I want the answer in terms of pi. So, excuse me, kind of like lay your pencil eraser over top of the pi, hide it for a little bit. Everything else that you see needs to be typed in this calculator to get the big fraction, okay? So I'm going to leave my pencil there, and I'm going to type this in. So alpha y will help me get the fraction. 51 over 360 times, and then whatever's left. So 16 squared. Now, it's going to spit out the fraction, and I want you to use that fraction. Okay? Don't give me a decimal. I want this fraction. And I know it's going to look weird, but remember, look at the fraction we used. We used 51 out of 360. So what the calculator's doing is, first of all, it tries to reduce this fraction if it can, and then it multiplies it with 16 squared, which is actually 256. So it's trying to combine that fraction with a big number, and it ends up with this improper fraction. That's fine. That's what I want you to use. And so we're going to put down 544 over 15. And then we didn't use our pi yet, so we just put a pi on it. And this would be feet squared as units. Now, I know that looks strange. It is a little strange because it's a fraction of the total area. It's not the whole thing. So if you want to see how big that is, just type that into a calculator. 544 over 15 pi. That's how much area that slice is. It's almost 114 square feet, if you think about it that way. All right? So again, the same thing. We have our central angle. I told you this, 3 millimeters. So I'm not stressing this too much, but think about the units of this problem. 3 millimeters. Let me just show you. This is just random. So you see on a ruler, this old ruler, those ticks between 0 and 1, 0 to 1, that is 1 centimeter. Okay? So that little distance between 0 and the first little tick, that is really hard to see. I'm sorry. But that little distance, that's 1 millimeter. So we've got 3 of these little things. That's how big our circle's radius is. Okay, so just imagine how small the circle's going to be. All right, area, the angle over 360. That is terrible writing. So 84 over 360 times pi times 3 squared. So now remember, cover up pi. Do it this way. Cover up pi. Whatever else is left, we type it to the calculator. So we had our fraction, 84 over 360 times 3 squared, and we get 21 over 10. So this is going to be 21 over 10. Put your pi, and then our units were millimeters squared because this is area. All right? So that's area of a whole circle and a sector. I don't think it's too bad. But when you get to your problems, if you're struggling with these sector problems, please let me know and I can help you. All right. Now, last thing about circles is going to be circumference and arc length. And so hopefully we remember circumference. Remember, circumference is like the perimeter of a circle, except perimeter is straight lines and circles aren't, so we have to call it something else, and we call it circumference. So circumference is all the way, the length all the way around a circle. It is one dimension, okay? It's not like area. It's not something squared. It's like all our area problems we did yards squared, feet squared, whatever. Circumference isn't going to be that way. It'll just be yards or feet or inches or whatever. Okay? So hopefully we remember circumference we call with a C, and you hopefully remember it. You probably think 2 pi r. And here's why, because the 2 pi is a constant. And again, we usually like to put pi at the end, so you can think of it as 2r pi. Or, so one of these will work. Or, if you know the diameter of a circle, you actually can get circumference a little bit faster, because you can say that circumference is your diameter times pi, d pi. Because remember, the diameter, let me put it down here closer where it's at. So diameter is 2 times your radius. So that's how these are connected. Okay? Either one of these will get you circumference. I don't care which one you use. Now, arc length. Remember, an arc is a portion of the outside of the circle. So it is actually a fraction of the circumference. Okay? So it's very similar to the idea of a sector, except instead of a fraction of area, it's a fraction of the circumference. And so again, we're trying to find this L. I'm going to call it AL, but whatever. So if we say AL for arc length, we're still going to do x over 360, so the central angle they give us over 360, but this time it's going to be times 2r pi, or 2 pi r, whichever one you want to think about. I'm going to do 2r pi. All right? So arc length is this formula now. But remember, after the fraction, you put circumference formula, not area, because this is arc length. So this should be circumference, a part of the circumference. Okay? So the diameter is 26 yards, so I'm going to use this one. I'm not going to worry about finding radius. You don't have to. So it's just 26 pi yards. And that's it. And also, we're again leaving it in terms of pi, so we need to see pi in our answer. But if you wanted to know how big that really was, just do 26 pi in the calculator. So that is roughly 81.7 yards. If you want to think about it in feet, multiply it by 3, so it's about 245 feet around that circle. Okay? If you want to think about it that way. But for us, we're going to leave it there at pi. Now I know my radius on this circle, so I have to use 2 times radius times pi. And then just type that in. That's going to be 5 9.8 pi feet all the way around that circle. And if you want to really know how big that is, type it in. It's about 18 feet around that circle, a little bit over 18 feet. Remember, these are not squared, they're just regular, because circumference and arc length is one dimension. It's a length. It's not two different things. It's not area. It's not like an area problem. All right, arc length. So they will give you this little bolded section that they want you to find the length of. But you need to know your radius and the central angle. And we know all that, so we're good to go. So arc length, the angle over 360 times 2, my radius is 15, times pi. And just like with sector problems, we're going to cover up the pi. Everything else we see, we type into the calculator. So alpha y, 38 over 360 times 2 times 15. And we get 19 over 6. That's what I'm going to use. If I could draw a straight line. 19 over 6 pi, don't forget pi, and then we had inches, so we're going to put inches. And if you want to know how big that really was, you could type into the calculator. Whoops, wrong one. 19 over 6 pi. Make sure you put pi out to the side. So that bold length is about 9.9 inches long. It's almost 10 inches long. Okay? So same thing, my angle is 107 over 360 times 2 times 6 pi. Type everything in but the pi into a calculator, and it ends up being 107 over 30 pi yards. And if you want, you could type that in and see how long it really is, but I'm not going to. Okay. So that is all about circles. Their area, circumference, and then area of sectors and arc length. So, and I'm glad I split these videos up because they're both about 25 minutes long. So make sure you watch both videos. You can do one at a time. So you could watch, never mind, I'll put that in the instructions what you can do. But make sure you watch both these videos and get your homework completed. As always, if you have any questions at all, please let me know.